Okay, so we're going to talk about domain and range some more today, and we're going to first do a quick review. F of x equals 2x plus 3, and remember that f of x is really like saying y equals 2x plus 3, and this graph is a line, and it's going on forever in all directions. So my domain, which is my x, is what happens from left to right. And if I look at this graph, it's going up, but it's also going right forever. It's going down, but it's going left forever. So my domain is all real numbers, meaning I can have all of the decimals and fractions in between, and it never ends. The range is your y values, and so that's y, or sometimes you might see f of x, and you have to know that that's still your range, and it's what happens from bottom to top, right? So bottom here, it's going down forever, and it's going up forever. So my range is also all real numbers. And then if I look at number 2, it says a taxi ride costs an initial rate of $3, which is charged as soon as you get in the cab, plus $2 for each mile traveled. So this goes back to writing equations from the beginning of school. $2 for each mile. That's your multiply word. That means you're going to multiply by x. And so my function rule is just a way of saying what's the equation. And my equation is y equals, and it's saying we pay $2 for each mile, so 2x, plus we had an initial fee of $3, so plus 3. And when we're talking about word problems, a situation, we need to decide what is it that we're really talking about. So independent is your x. What does x stand for in this situation? Well, $2 for each mile. So x is the number of miles. And y is your dependent. And here my y is my total charge. Or total cost. And when we write domain and range, we need to ask ourselves a couple questions. One, we specifically look at the independent, the x, the number of miles. Can you have negative miles? No, can't have negative. And can you have decimals? So when we talk about miles here, you can have half of a mile. And so since you can have half of a mile, this situation is continuous. It's continuous because you can have decimals. And so you write your domain and range by using inequalities. Remember, your inequalities are less than, greater than, less than or equal to, greater than or equal to. So if I'm talking about my domain here, my domain is talking about miles, and I can't have negative, but I can't have 0. I could have 0 miles, and I can have greater than or equal to 0 miles, because I can have all the decimals in between. And my range has to follow along with the domain. My range is my y values. And if I pay for 0 miles, that's like plugging 0 in for x. And so 2 times 0 is 0 plus 3. So y is greater than or equal to 3. Okay, because no matter how many miles you travel, even if you don't go anywhere, but you called that taxi, you still have to pay $3. All right, let's look down at number 3. So number 3 says a banquet hall charges $15 per person plus a $100 setup fee. So there's your keyword, per person. The cost is a function of the number of people that attend. So my function rule is y equals 15 per person plus $100 to rent the banquet hall. My independent, my X, is number of people. My dependent, the Y value, is the total charge. And so again, you ask yourself, can you have negative people? Well, no, negatives don't make sense. Can you have a decimal of people? Can you have half a person? And no decimals. Even my 4-year-old is a whole person. He's just tiny. So my domain then, and my range, this situation is discrete. Why? Because you can't have decimals. And so if it's discrete, you must list out the domain and range. So my domain then is how many people can come to the banquet hall? Well, 0 people could come, or 1, or 2, or 3, and so on. And then my range is my Y values. And if 0 people come, how much money is that? And I'm going to show you how to use your calculator to get this answer. So on the calculator, if you go to a graph page and you type in 15x plus 100, you can see your graph. But remember, if you press Control T, it goes to your table. So how much is 0 people? 0 people is $100 for the banquet hall. And then 1 person would be $115 because it's $15 per person. And 2 is $130. And 3 is $145. And so on. And we don't know how many people are going to come, so we're just going to put ... But this uses what we learned last week about function notation. All right, I'm going to skip number 4. And we're going to go on to actually number 6. Okay, number 6. A small pepperoni pizza at Bill's Pizza contains 1,000 calories. Sam ate between 2 and 5 pizzas this week. Okay, so the independent here, or let's just start with our function rule. Our function rule is that each pizza is 1,000 calories. So my equation is just y equals 1,000x. And here, x, your independent, is the number of pizzas Bill eats. Or Sam, sorry, not Bill. Sam eats. And my dependent is the y, which is the total number of calories. And when we talk about discrete or continuous, we ask ourselves, can we have negative? Well, I'm talking about number of pizzas Sam eats. We can't have negatives, okay? Can I have decimals? And the answer here is yes, I can have decimals, which makes this continuous. Why? Because you can eat part of a pizza. You can't buy part of a pizza. You can eat part of a pizza. And I guess maybe it depends on where you go if you're buying part of a pizza. Anyways, this particular problem, Sam ate between 2 and 5 pizzas. So that's my domain. And since I'm continuous, I use inequalities between 2 and 5. And so here we would say it's the set of real numbers because I can have decimals from 2 to 5. And then my range matches up. So it's like plugging that in, or it's like using your calculator. And so if I'm on my calculator and I can add a new graph page, and I type in 1,000x, and I go to my table because that's what's useful right now. And if he eats 2 pizzas, that's 2,000 calories, which you may have figured that out without using your calculator. And if he eats 5 pizzas, that's 5,000 calories. And range is Y, and we put our inequality symbols. So it looks like that. So the range is a set of real numbers from 2,000 to 5,000. All right, and then number 7. Excuse me. The total cost Avery spent on a sandwich and several bags of chips can be found using the function c equals 0.75x plus 4, where x is the number of bags of chips she bought. She bought at least 2 bags, but not more than 7 bags of chips. So our function rule, they gave it to us, c equals 0.75x plus 4. And it even told us what that independent is, number of bags of chips. The dependent is the total cost, that's the y. And so again, we ask ourselves, can we have negative bags of chips? No. Can I buy a decimal, a fraction of a bag of chips? And the answer is no, which makes this function discrete. You can't buy part of a bag. You could eat part of a bag, but we're not talking about eating them. We're talking about buying them. So you have to buy them in whole bags. And so my domain then, if it's discrete, is a list of numbers. And so they said that she bought between 2 and 7 bags. So I listed out 2, 3, 4, 5, 6, and 7. I could also make a table, X, Y table, which might be helpful later on. 2, 3, 4, 5, 6, and 7. And so I need to figure out these Y values in order to write out my range. And before we do that, it says the domain is a set of integer numbers from 2 to 7. Integer meaning I can't have decimals. So now if I go to my calculator and I type it in, so Control Doc adds a new graph page, and it's 0.75x plus 4. And I go to my table, Control T, and I need to find what does it cost at 2? Well, $5.50. At 3, it's $6.25. And as I'm doing this, I'm writing it down on my paper. So my paper I'm filling in those numbers. And so 4 is 7, 5 is $7.75, 6 is $8.50, and 7 is $9.25. And so I use my calculator to figure out those answers. And then I'm just going to write my range as a list, and I'm just going to rewrite those numbers. So the table is just there to help you figure out what it is that you are looking for, and your calculator will give you those numbers.